Saxon Algebra 1, Lesson 68. Well, we have one of those lessons with a fun name. John actually called it More on Complex Fractions. Sometimes he will say advanced. Sometimes he will use the word complex, although it's harder to say complex fractions. Sounds like you're stuttering. But more on is another way of saying we're digging deeper. We're making them a little bit harder. We're baby stepping into another version of a problem that we have already tried before. So it's complex fractions. We have been doing these for a while. They are a little bit harder. I will explain as we go. All right, this is what John gives us. You see that much and you go, oh, that's not so bad, I can do that. But that's only the first half of the problem. That's what we have to deal with. That's the whole thing. We learned that complex fractions means any rational expression. That's a fancy name for a fraction with letters. A rational expression that has more than one division bar line means it's a complex fraction, and our job is to simplify it so that there's just one bar in the end. One line. We can't make it completely go away, but we can get it down to one. The way that we do that is by going to the denominator, and again, I exaggerate my line so it's really easy to tell the main denominator, and we want to turn that into a 1. That's our goal. Turn the denominator into a 1. The way that we do that is by making this into one fraction. That's what we're going to do in just a second, and then multiplying by the reciprocal. All right? So the first thing we do is we smoosh these two together. One of my students, how many years ago? It's been probably 6 years by now. You may know her. Her name's Evie Jones. She made up this really cool name for this style of problem, and I really like it. She calls it the smoosh and flip. This is the smoosh. We have to put these two fractions into a single fraction, and happily that's going to be easy because their denominators already match. So we can rewrite this as x minus 1 over y. Now we're ready for part 2 of Evie's linguistic masterpiece. We now multiply by the reciprocal, and that's called the flip. It's the smoosh and flip. Oh, you'll never forget it if you think of it like that. So we multiply this by its reciprocal. It all turns into a beautiful 1. Poof, disappears. Right? When the denominator is a 1, we can put it in or take it out as we bloody please. However, because I multiplied the denominator by this, I have to do the same up here. Now I'm leaving myself space, and you'll see why in a minute. Let's just pretend I wanted to write these two over each other, which is a perfectly good reason to write it where I did. All right, so we've accomplished our mission in the denominator. Now we just have to clean up the numerator. And we're like, oh, we're all ready. Let's multiply by the reciprocal, but we look over here and go, oh, dang it, we have another smoosh situation. So we're gonna have to smoosh these, which again, John has set it up so it's perfectly easy for us. And now we have to multiply these two. I do recommend slap some binomials. Binomials are like ones and denominators. You can put them in and take them out as you see fit. I want to make sure that I don't screw anything up with my multiplications, but then I notice, oh look, the y's just cancel. So my final answer is x plus 1 over x minus 1. Happy times. This giant beast, we smushed and flipped it into submission, and that's what we ended up with. I like this much better. I don't know about you. We completely got rid of the y's. Yay. Okay, smoosh and flip. As we go on, That is always going to be our strategy, smoosh and flip. It's just going to get trickier and trickier to do those things. But we are fine. We can handle a little smushing and flipping. Let's see how many examples there are. I like to tell you so that you're like sort of mentally on board. Like this one is 5 examples. It's kind of a lot, but it's nice because we will have different styles of these problems. And then when you're doing your homework, each one will look a little bit familiar because as you see when we do this one, it looks a little different. And what's different about this one is, first of all, a number. Whoa, that's not just 1. That's kind of weird. And secondly, it's so simple. The presentation of the problem is so simple that it looks hard. So we know, okay, go to the basement, turn it into a 1, use the good old smoosh and flip in order to do that, to turn it into a 1. But we look down here and we go, there's nothing to smoosh and there's nothing to flip. Okay, so nothing to smoosh is good news, but we can always flip, right? Because we can always take the reciprocal of a number by putting it over 1. So now I'm going to multiply this by 7 over 1. I left a little space here. Whoops, 1 over 7. Sorry, my bad. This equals 1. You don't have to write this, but I take great pleasure in it, and I think it makes it easier for you to remember. If I was a student, I would write the 1 over 7. I would write it up here as well to make sure that it was really clear I was doing the same thing top and bottom, and then I'd go, boom, you're done. Now, up here, all we have to do is multiply by 1 over 7, but we have to smoosh first because this isn't smushed. This time, John's making us sweat a little bit to get our denominators. We need a denominator of x, so we're going to multiply this guy by x over x, which is fine because that's equal to 1. Cross that off. And now we'll get x plus 1 over x. You with me? And now all we can put parentheses on this. Again, I would rather be safe than sorry. We multiply straight across the top, straight across the bottom. We get x plus 1 over 7x. Cute, right? That's not so bad. Let's try the third one. One over x, 1 minus 1 over x. All right, it's repetitive, isn't it? But it looks cute, it looks simple. We just remember our simple rules. Go to the basement and start the smoosh and flip. Smoosh. Okay, to get these into one fraction, we have to change this so it's got a matching denominator. Just like we did last time, we'll mentally multiply it by x over x, and we get x over x. So this equals x minus 1 over x. We have successfully smushed. Yay! Now we flip. I'm going to write this one more time because, you know, it just makes me so happy to show that we turned it into a 1. Before I cross it off, I'm going to go up here and write this, though. Right? Because this has to be the same. It's called the numerator-denominator same quantity rule. I consider that a major mouthful, and I don't like to say it, but whatever we do to the bottom, we have to do to the top. There's where we're doing it. Now we're just going to multiply straight across. The x's cancel. That's pretty cute. 1 over x minus 1 is all we have left. Oh, isn't that fun? Notice the way I lay these problems out on my paper. It is a minimum of work. You don't have to do this. All you have to do is write. Once you multiply by the reciprocal, you can just do that. Cross it off. You don't have to write that. Otherwise, I want you to do it exactly like this. Give yourself a little bit of room up here because you never know when you might have to smoosh in the top. Like here we had to. Here we didn't have to. But give yourself that room so you don't have to recopy stuff because that's annoying. All right. So we have 2 more examples. I wonder what John has in store for us. Won't it be fun to find out? I don't know, you guys. If you enjoy this, 1/10 as much as I do, I'm happy. I just enjoy this, nothing more. I love though when my friends will be telling me about some drama they're having in their work and they go, "Ugh, we have so many problems at work." I'm like, I'm a math teacher. You want to talk about problems? That's all I do. I do problems every day. I always enjoy that. Other people are like, I see what you did there. Okay, ready? Number 4. A over B plus 1 over x over b plus 4. Okay, this is kind of weird. No denominators, but our strategy is always the same. Go to the basement, turn it into a 1, use smoosh and flip to do so. So let's smoosh. I'm feeling like writing it this time. Smoosh. Okay, that means we have to have matching denominators. This needs to be multiplied by b over b. And then we get x plus 4b over b. And now I'm ready to flip. There's my flip. And before I cross it off, I better write it up here too. B over x plus 4b. Make sure when you're copying this up, that's why I like to do it above, it's really easy to mess up and copy the original fraction and not the reciprocal. The reciprocal is the one we have to multiply top and bottom, not the original fraction, not the smoosh. This is the smoosh number. We need to multiply both by the flip number. So that's why I like to draw them over and above each other, and that's why I often put that box around, because it just helps my eye make sure I'm doing top and bottom the same. Okay, now I can see that all cancels, and I'm just going to do this. The whole thing goes away. Oh, happy days. All right, now I'm going to multiply this times the top, but my top needs a smoosh, doesn't it? So let's see, I want it to be b, so I'm going to change this. Look at this. Oh, I just changed that 1 into a b. b over b is equal to 1. I'm good. So this equals a plus b over b. Now I multiply. I like to put parentheses around my binomials. In this case, the b's are going to cancel, and it turns out to be perfectly harmless, but you just never know when it's going to be crazy. So these cancel, and I have a plus b over x plus 4b. Can we cancel those b's? No, we cannot, and I'll tell you why. We can only cancel when we're multiplying. This b is being added to the a. This b, yeah, it's being multiplied by the 4, but that's being added to the x. So neither of these guys are in a position to be canceled. If we could, if it was set up properly, we could factor out a b, but we can't do any factoring in these. But that's a way that we sometimes can cancel in an expression like that, but we cannot cancel unless we're multiplying. You're welcome. Last problem, ready? Here we go. Oh, this is a tricky one. Okay, this one has negative exponents in both the numerator and the denominator. And we have to remember how those work. The trick here is to remember that when you have an addition sign in the middle, then you have to handle each of these separately. You can't flip the trapezes down together into a new denominator. They have to be separate. So this is going, this first term, the x stays up, and the a goes to the bottom. I don't need the 1 anymore. That was just there to hold the place of the minus sign once I kick it downstairs. I mean, flip it off the trapeze. I mean, push it off a cliff. Then I can poof the 1 away. It's only there when I needed the minus sign. Plus, and then the same thing, we're kicking the b downstairs. Draw this, and now we have to flip him as well. Give him a 1 because he doesn't have any numerators. All right, so this plus sign is what created the drama in the way that we had to make those separate fractions. I remember encountering that rule, and my teacher never explained it to me that clearly, that it's the minus sign, the plus sign rather. A minus sign would cause the same problem. Plus or minus are going to cause us to create two little fractions instead of one big one. If we were multiplying all this, we'd be fine. We would just make one big fraction. But alas, so we have to do this nonsense, right? So now we are ready to smush and flip. This is going to be easy because all we have to do is multiply by x over 1, and it's gone. X over 1 up top, just to make sure I'm in balance. This all goes away, and now I'm just straightening up my top. I didn't even have to smush. All I had to do was flip. Here, we're going to have to multiply this one by b over b, and this one by a over a, right? Our least common multiple is ab. I feel like I'm too far down. My least common multiple is AB, so I multiply by the missing pieces, top and bottom, and I get, I'm going to write it alphabetically, BX plus AY over AB. Okay, there's my smush. And now I am ready to multiply by the reciprocal. Again, I'm going to do that, and I'm going to write my answer up here. Look at what I can do. X on the outside, bx plus ay all over ab times 1. This is our final answer. If we had an x in the denominator, we don't, but if we did, we could cancel these because this x is only being multiplied, okay? We couldn't cancel this x, and we can't cancel the a or the b, but if there was an x down here, and I'm assuming we were multiplying by the x down here. If it was ab plus x, no, that wouldn't work either. Okay, so be careful when you cancel. Make sure that you're multiplying and not adding the things you want to cancel. Okay, guess what? And we can leave it in this form. We don't have to distribute the x. Oh, those are kind of fun, aren't they? More on complex fractions. We're going to add to this as we go on into Algebra 2. We'll just keep making the original problems just a little bit harder, but it's smush and flip from here on out. Thank you, Evie. Evie now, well, I don't know if COVID has gotten her back. I think it has, but she works on a cattle ranch in Texas, I'm pretty sure. I don't know if you know Evie and you have an update on her, you should tell me. I haven't talked to her in a while. I talk to her mom every now and then, and her sister sometimes too. Both former students of mine, Esther and Evie. Anyway, that is the end of lesson 68. I hope you do not get distracted by my ramblings at the end. Where are we? 68. That's the end of week 18. Oh, how the time flies. Okay, thank you, bye.